Okay, this video is to help you plug those definite integrals into your calculator. I want to show you how to do this using the first problem on that textbook scan. So you can see I have up here, I have the graph and then the functions. Even over here I have the work solving for where these two functions intersect. Okay, so since they intersect at 0, at x equals 0 and x equals 4, I had to do that solving over here to find that other one. Or you could have calculated that on your calculator by calculating the intersect, but here is what the integral would look like. Okay, it would go from 0 to 4, and it would be the line, because that's the top curve, minus the quadratic, and then your little dx, which I almost forgot there. Okay, so then this is the work I'm ready for you to start skipping, okay? I think you understand how to take an antiderivative, and I think you understand how to apply the fundamental theorem of calculus. You can see here I only plugged in 4 because obviously plugging in 0 doesn't do anything. So how do we plug this into our calculator? We actually would plug this into our calculator so we wouldn't have to do any of this work right here. So I have two of my calculators to show you how to do this because it does kind of differ depending on the age of your calculator. Okay, but actually both of them, the first step is to hit Math 9. Okay, so you see 9 is this, it has the integral in there, so you can see it here. You can't see it down on this one, but it looks the same. So you'd just hit the number 9. Okay, so then you can see how it looks very different, okay? A newer calculator is gonna be much easier. You can definitely just see exactly what you're plugging in. You know, a lower limit of integration of 0, and then you hit next to 4, and then 4x minus x squared dx. Okay, over here, sorry, not so easy. You hit enter, you should get 10.6 repeating. So over here, you have to plug in the function first. So the function 4x minus x squared. Okay, then you've got to hit this comma right here. Then you have to put the variable which you're taking the antiderivative with respect to. So you have to put comma x. So you will always do that after the function you're taking the antiderivative of. And then comma bottom limit of integration, comma top limit of integration. So comma 0, comma 4 in this case. Enter. You get the same answer, just a little bit more work maybe. So it's always function, comma x, comma bottom limit, comma top limit of integration. Okay, so the other thing I wanted to go over real quick is 1b, where you do this in terms of y, and it should look like this. But I also want you to not have to go through all the work of taking the antiderivative. I want you to save some time. So this one you can also plug into your calculator. However, I just want you to know when you plug this into your calculator, even though it's y on your paper, you're still going to use x in your calculator. So that's math, then the number 9. Okay, this time the limits of integration are y values. So I'm going from 0 to what's the y value that they intersect at? That would be 16. Okay, so 0 to 16. And then bottom function minus, or top function minus bottom function. So the top curve this time we're calling the square root of y, but again, you still just type it in as the square root of x in your calculator because that's really the only variable that your calculator has. Minus x over 4 in this case. But notice, sometimes when it does these, it does spin a little bit because it is doing a lot more calculating than, you know, what you've done in the past, but you get the same answer.